All right. Hello, everyone, and welcome. I am back on Twitch this time. Welcome, welcome. Just give folks a few minutes to file in here. So, while people are joining the stream, I will mention that last week I mentioned that I was going to be streaming on YouTube for a little bit. However, it didn't go quite as smoothly as I'd hoped. I had a lot of connection issues and just various things that didn't make it go quite as smoothly as on Twitch. And I think I like Twitch better. So at least for right now, I think I'm going to stick with Twitch. That doesn't mean that I won't ever stream anything on YouTube. But I think for right now, this is probably what I'm going to stick with. With that, we do have a couple of different things going on in this stream this week versus normal. So one thing that you may or may not notice is that we have a little bit of background music playing, which is something that I feel will add a little bit of ambience to it and make it a little bit more interesting. The background track is actually the OST from Heartbound, which is a game by Pirate Software. And he was nice enough to allow folks to use that if they wanted to. And it's a gorgeous soundtrack. I highly recommend you guys give it a listen. It really is really nice to listen to. If you're not aware of who Pirate Software is, he is here on Twitch. And he is another game developer. He typically streams from midnight PST till about around noon or so. I think that's what his schedule is anyways. Something like that. So he's usually finishing up around noon anyway. He streams for probably 8, 9, sometimes 10 hours a day. And he's on every day. And I highly recommend checking his channel out. In fact, let me go ahead and do a shout out. So go ahead and follow him as well. His stream is really good. All right. So with all of that said, we are going to be basically picking up where we left off on stream last time. And I have gone ahead and done a bunch of work off stream. And so we're going to be kind of walking through that because, as I mentioned a couple of streams ago, that this material redux and terrain work has been taking quite a long time to actually get through. And so what we're going to do is we're actually going to finalize that tonight, at least for right now, because we actually have a lot of the work done, and I've gone ahead and added the additional things that need to be done after that. So what we have is a series of commits that I've made, some of them larger than others, to go ahead and complete these features. And the reason I did this is because we want to move on to something else in the series, and I feel like we've spent enough time on this for now. So every once in a while on a larger feature, I may wind up doing that just for the sake of brevity, right? So we have basically this massive pull request that is going to be pulling from the terrain materials branch that we've been doing all of our work in and putting that into main, and that's going to go in tonight. So we also, if we look down here, we have all of the commits that we've made before. So this has to do with all of the material work that we've done, as well as all of the terrain work that we've done all along the way, right? So this kind of includes everything. But the things that we're going to be looking at tonight are specifically work that was done after last stream. So if you guys have any questions or comments, please, drop them into the chat. This is an interactive stream. I'm more than happy to interact and talk with you guys and things like that. So with all of that said, let's start diving into the changes. So hopefully this isn't going to take too long because we actually want to kind of revisit the roadmap and see what we're going to bite off next, right? So one of the first things that I did was I tweaked a couple of the material files. So the cobblestone file, I just tweaked the shininess value in that to something a little bit more unique. The terrain shader, receive some updates. So this is the fragment shader. And what we've basically done is we have adjusted some of the padding because we had some alignment issues with the data. So instead of having our material info structure diffuse color, shininess, and then padding, we have diffuse color, padding, and then shininess, right? So this is the old version. This is sort of the new version down here. We also have this structure material terrain properties that has been extended a little bit. So this now, instead of just containing something called material info, actually contains material fong properties, which matches up with what we have on the C side. So that is what we're looking at here. So we've gone ahead and renamed that from material info to material fong properties and use that here. So we have our materials here, and then we have a padding here, and then we have a number of materials here with a padding behind that as well. Now, all of this padding is necessary because of the size of this. So whenever you have a structure, you have to pad out the rest of your data to sort of match in blocks of that size of data, right? And so that's what we've done here. And eventually we'll wind up filling in these paddings, both here and here, with different stuff. And so, you know, we're eventually going to fill this in. It's not always going to be wasted space, but we have to have it sort of extrapolated that way for right now. Okay, so a little bit further down, actually, one thing I wanted to mention is the global uniform object, for some reason, had a model matrix in it. Makes no sense. Shouldn't have been there. So I removed that. We have this instance uniform object. That also needed a little bit of padding after the light structure. So we've gone ahead and added that. We have also the effects of our structure renaming here. So it's just from material info to material fong properties. And that's reflected in a few different places, right? We had an erroneous F here, so we've gotten rid of that. And then, whoops, actually, it looks like we forgot to get rid of a to-do about this mix not being quite right. So I've actually fixed that. So we may actually put in a separate commit to fix that comment. But basically what we do here is we loop through all of the materials. In fact, I actually think I fixed this in a later commit. So ignore that for now. But basically, this is where we loop through all the materials and extract the properties out of them, right? So the rest of this just has to do with that rename of the structure. So that's it for that file, right? This is most of where most of the shader work was actually done. So the next thing is in the vertex shader, which was actually mostly removals. We didn't need this constant in here for the point light max, and in fact, we didn't need any of this point light data in here whatsoever, so we've removed that. Again, the global uniform object had a model on this side too, a model matrix. I'm not sure, that must have been a copy pasta or something. So I've removed that. And then the global uniform object also still had the point lights in it. And that should have been in the instance object, right? And that's actually only used in the fragment shader, so we don't need it here at all, so that was removed. We've also added our push constants back with the model matrix here, right? Just because we're going to have potentially more than one terrain, so we need that. And then we have also moved the model from global UBO to push constants in a few places, and that was really it for the vertex shader. Okay. The shader config for terrain has changed as well. So we just adjusted the structure size to take into account the padding for that on there, and then we added the uniform padding on there, and the model matrix we put back in the local scope, right? So we've removed that from here and just put it down here just to make it, you know, sort of split up. So that way we have all the globals up here, the instance variables here, and then the local variables there. We also, in the terrain, the k-terrain file, we swapped out this height map, which I think actually gets swapped out again in another commit. One of these other commits, I think, swaps that out a second time. And I'll go over the reasons for that in a bit. And then we also went ahead and filled out some additional materials here. So we have floor, paving, paving 2, and roof. And these also actually wind up getting swapped out as well. But we went ahead and just filled those out. All right. So that is those files. Wow, this expand up thing is really annoying. Okay. In the render view world, we actually... looks like we had a bug here. So when we were, let me expand this up actually a little bit. So we were actually looping through the terrains, right? And when we were actually going to apply the local and draw the geometry, we were drawing the geometries instead of the terrain geometries, which was wrong, obviously, because we're dealing with terrains here, right? So this is a copy pasta from the other place where we're actually drawing all of the geometries in the scene. So that was just a bug fix there. Resource types received some updates to make the structures match the shader side, the GLSL side. So we have our material fung properties where we added our padding here. And then we have gone ahead and gotten rid of the terrain material info structure because we wound up actually not needing that whatsoever. We could just use the fung material info. And so we actually wound up getting rid of that structure, and anything that references it is gone. And so to reflect that, we have the material terrain properties, which no longer is terrain material info, it is material fung properties, right? And then, of course, we have our padding in here that we've added. So that is that for the major type changes anyway. In terrain.c, we actually went ahead and commented out this weights, just setting everything to use the first material. And we started off randomizing it. This is ultimately not what we did in the end, and you guys will see that. But this is one example of a way that you could assign vertex weights if you wanted to. So that's that. The material system is probably where I would say most of the updates happen, right? So this is definitely by far the largest update file. So let's actually come back to that and skip it and come back to some of these other files, and then we'll hit that one. So the shader system looks like I just added a little bit of missing punctuation there, so that was just a tiny bug fix in the logging. The texture system was missing some checks for default texture names. So we've gone ahead and added those things in, along with some warnings if we're going ahead and acquiring a texture with one of those default names. So that's all that is. And then the renderer Vulkan backend, actually, I should reverse that too, because that change isn't actually needed. I might have done that in a feature pass. I was testing something there, but it didn't wind up actually being needed. So uniform set, I undid a little bit of the auto formatting that was done to just put this back all to one line. And then what we do here is just a cold cast of the value to a map, so that we can reuse that map variable and not have to be casting it all over the place. And so this is that. And that also helps us when we're debugging it, because you could just kind of hover over it and see what its value is with all of its typed information. And then our internal states instance texture maps just uses map instead of this value, right? So it's just reflecting that small change there. Okay, so that is everything minus the material system. So the material system obviously got the bulk of the updates in here. So one of the first things that I noticed was we were still storing diffuse, specular, and normal texture in the shader locations for the terrain shader, which is obviously wrong. We don't have those anymore, so I removed those. And then I also removed num materials out of here because that's actually stored elsewhere. I also removed the terrain material properties structure that was private to this file because that was actually located elsewhere, right, in that header file that we saw earlier. So we don't need that here. Here is just removing those additional locations that we're no longer using. and getting those locations from the shader itself. So we remove that. Here is where we're just swapping out some of those terrain material properties for the renamed version of that, which is now material terrain properties. And that's to make it match what is in the GLSL side, right? So we just renamed that structure. We're adding our padding in here and setting that to 0, so it's really obvious when we're looking at render doc or something that those should be zeroed out. And then here, we just changed up our mapping logic just a little bit. We split up the map count into its own variable, and then we could just use that here and here, right? And then here is our loop for the materials. So this is for each material, right? So we have a terrain max material count that we've defined in the header file, and we basically just loop through that. I renamed I to material IDX just so it's a little bit more obvious what's going on. And then here we go ahead and get a pointer to the material properties, and then we do a quick check to say, well, we're going to start off with the default material. And if the material index is less than the material count, then we're going to go ahead and get a pointer to the actual material. So we actually were somewhere up here, a little bit further up, we actually got an array of materials. Let's see, I think that was maybe a little bit further up. We have materials. Where is that materials array? I know it's in here. Here it is. So we get all materials by name, right? So we do this by the material count that we actually have in our configuration, and then everything else is using the default material. So that's basically what this is doing, is it's saying, hey, start off with the default, and then if we happen to be at a material index that should have a material assigned to it, then we go ahead and we set the pointer to that material instead. The next thing is we set, we go ahead and grab a pointer to the material flung properties, which is just in the reference material properties, right? So we just get a pointer to that for convenience. Here we go ahead and we loop through the maps. So I just added a little bit of information here saying what those maps are. And then instead of getting materials sub I maps sub j, I just put these renamed properties in here, right? Just to make it a little bit clearer as to what that is. A little bit further down. So we have, let's see, what is the change we made here? We have map count was already done further up. So we just use max map count for that. We allocate an array large enough for the max map count, not just the map count, but all maps, right? All maps that the shader could possibly use, because we still want to reserve those things and apply default maps to it. That way, later on in an editor, if we want to add something to an available slot in the material editor, all we have to do is change that reference. We don't have to allocate new memory or set up a new shader or anything like that. We can just kind of swap it in and it's good. So that's where we're doing that. We also are, for our instance resources, we acquire enough for the max map count instead of just the regular map count. That's the reason for that change. And here we clean up the maps afterwards, right? We also had a bug in here for where we're using material locations instead of terrain locations, which are obviously going to be different because there's different shaders. So we've gone ahead and swapped those out. Let's see. So the next thing is we actually were missing a block here to check, and this is material system apply local. Whenever we were applying that, we were not checking to see if we were actually using the terrain shader ID. And so we just needed a uniform set by index for the model matrix on that, right? We didn't have that before, so that was an issue I ran into as well. Here we're just setting the padding to 0 because since we've added that, we don't have to do that, but we're doing it just to be explicit. And the other benefit to doing this, by the way, is if we change the structure to get rid of the padding, or we change the type of the padding to add another variable or something like that, this will actually wind up throwing an error because it'll be the wrong type, which will say, hey, here's another section of code that we have to update to reflect that change, right? So there's a couple benefits of doing that. So it looks like here I just moved the comment inside that block. This is the shininess. I just moved the comment inside that block and added an else here, because obviously if we get to here and do this, we're going to break out of the loop, right? Or otherwise, or actually we're not going to break out of the loop. That was a bug. So we removed the break statement from these because it broke out of the loop and didn't actually handle copying all the properties, right? So that was another bug we had. So what we do in here is we add an else if, and that way we only execute this or this, right? And we don't have to have a break statement in here to sort of keep from falling through. So that's the way it should have been in the beginning. Not sure what I was thinking there, but it is what it is. Okay. The next thing is in create default material. We actually were missing some logic to add in the texture maps. So we've gone ahead and set some of the texture map properties here on there. And then here's just more for that structure rename. And that's it, right? That's most of what we are missing for the terrain stuff to actually work. And so we have terrain multi-materials working. The blending at that point was kind of foobar. So that's pretty much it for that. So we'll move on to this next change, which I think is actually mostly material and asset changes. So we've gone ahead and grabbed some new files, some new textures here, right? So we have this sort of crusted snow texture with a normal map and a specular map. We have this grass texture with a normal map. We didn't have a specular for that, so that'll just fall back on the default. Then we have this river rock texture with a normal and a specular. And then we also we added a smaller terrain height map, so 256. We renamed height map 2 to height map 512 because the default size was 2048. And we don't always necessarily need height maps that large. Like a 256 map is actually quite large, as you guys will see when we actually get ready to run this stuff. So that was definitely a change that was needed, right? Because we don't need to be loading huge maps there. And then finally we have this wavy sand, which is just sort of like a beach-like texture, right? So we use that, and that is accompanied by material definitions for all those things. So let me just collapse some of this real quick. And we will, let me scroll to the top of this list actually. And Safari Miner, thank you so much for the follow. I appreciate it. Okay, so as you can see, once I've sort of collapsed those textures, this scroll bar isn't all that large, right? So the amount of code changes here is actually kind of minimal. So we've gone ahead and created new materials for this. I found it easier to go ahead and create materials just sort of in the version 1, and we'll convert these to version 2 later. I'll probably write a utility that does this actually. So we have this crusted snow 2 texture that reads in, or that uses those. I updated the Falc rec material to properly have the padding like it should. So any of our new materials are going to have to require that padding variable be written out. So I updated that because that was a bug. Grass 1, here's the material definition for that. Again, nothing too crazy to look at. Here's the river rock material definition and the wavy sand definition, right? So that's just all assets is all that is. I also updated the scene file. So we've changed the ambient color a little bit. We went ahead and uncommented the Sponza scene so that we can see that again. And I changed the transform on the Falcon mesh just to kind of move it to a different area that makes a little bit more sense for what we're looking at. I moved the point lights as well. So, again, nothing crazy there. Now we have a couple more updates to our material shader. So that also has to have a padding update. So we did it on the terrain before and the material Phong properties, but we didn't actually do it by the material shader that uses that. So we had to put that in here as well. I also put a note in here to do this in the future, which is to make the directional light a global, because it doesn't really make sense for that to be the instance, right? It should be in the global, but I didn't really want to make all that change right away. So that is pretty much that. The terrain shader received a few more updates. It looks like I didn't clobber that to-do statement though, so I may still wind up having to do that. We'll see. So basically we start off with some defaults here. So the diffuse starts off with a white texture. The specular starts off with sort of a half-transparent gray texture, if you will. And then the normal map sort of defaults to a Y up, right? Which actually, come think of it, that should probably default to Z up, not Y up. So that's actually a bug too. But basically what we do is our normals and diffuses and speculars all pull from that array as we expect now. And there was a bug with that too, where we were basically just taking the sampler, diffuse, or specular offset and multiplying it by M, which was wrong. It should be M times the total number of maps we have for each material, and then we apply the offset after that. So I fixed that bug as well. Go away. Okay. Here we just updated the structure size of the properties for the material shader config, so nothing crazy there. We've updated the terrain to go from height map 2 to height map 256, just so we use that. I also increased the scale from 1 to 2, so that means that basically each individual pixel on the height map becomes 2 units of space in game, which is roughly equivalent to about 2 meters, right? That's sort of the scale we're going to go for. I also changed the materials from these sort of basic ones that were pre-existing to Riverwalk 1, Wavy Sand, Grass, and Crusted Snow 2, right? So we have those new materials there being used. And K-Math. So we had to use a smooth step. We needed a smooth step function. And we needed this in code versus where you might expect in the shader. Because we wanted to actually store the weights data in the shader. So I used this to actually perform some interpolation between the various altitudes of the terrain and basically applied different weights of different materials from top to bottom in terms of altitude on the terrain. So the topmost layer or the topmost part of the terrain is basically going to be that snowy texture, and then below that we have the grass texture, and then below that we have the sand texture, and then below that we have the river rock, right? And eventually that'll be underwater. And so we use this smooth step to basically interpolate between those things, and this allows us to interpolate between different ranges, right? Is basically what that's giving us, right? And I'll show you guys the difference between doing that and just using full weights from one vertex to the next, and so that you guys can see, you know, how different that looks. The other thing is, let's see, there was a bug in the camera where whenever we called camera rotation Euler set, it was actually treating, it wasn't properly converting the rotation passed in, which should be in degrees. It wasn't converting those things to radians. So the Euler rotation internally expects that in radians, right? So it's a little bit weird. I might wind up actually just renaming this to just rotation because it's not an Euler angle at that point, but it is what it is. Okay. Safari, good evening. Just saw your chat there. Welcome, welcome. Okay. So in terrain.c, we just made a minor change here. So we kind of got rid of our random material weights thing here because that was just an experiment I was trying out. It looked awful, so I'm not going to bother showing it. And here is where we actually have our material weights, right? So we're basically saying that our Bumfuzzle Games, thank you so much for the follow. I appreciate it. Welcome to the stream. So basically what we do here is we say for basically the top portion of, I'm sorry, the bottom portion of the terrain in terms of the heights, we apply the various weights, right? So this allows us to say material weights 0 is equal to anything that's within this range will be interpreted from 0 to 1, depending on where in this range it is. And then anything outside of that will just be 0, right? And then it roughly works the same way for these other guys, right? So this is sort of the bottom fourth. This is like the bottom 2 out of 4, 3 out of 4, and the top, right? And I've also left this code in here to show you guys what that looks like if we don't interpolate it that way. So we'll come back to that. Okay, we're almost done here. So our material system needed a couple more updates because there were a few more bugs I found with that. And so what we've done is we added a destroy material first off for the default UI and default terrain materials because we didn't have those things and it should have. The other thing that we did, whoops, I've got some debug code in here, so I'm going to have to get rid of that as well. Let me see, did I get rid of that in the current version? I did not. Okay, so just so you guys can see it, I have that here. I'm going to kill this. Right? We don't need that. The reason that was there was material 47 actually had, it was a material that was defined with no maps whatsoever, no texture maps. And so that actually exposed some issues in here where we potentially didn't have different maps assigned. So this normal, diffuse, and speculative assigned true, that's what this was all about, right? So basically, if we don't have one of those maps assigned, we'd assign a default and set up a texture map for that, right? So we just kind of do that here. I probably am going to split this out to like a separate function that maybe just takes a couple parameters instead of repeating all of this because I hate repeated code. But for now, this does work. Yeah, so it's funny you bring that up actually. So I like to mark debug code with a certain macro or comment that I have a Git hook that will refuse to commit if it's still there. So actually, what's really funny is I actually have that set up on my work machine where I can just put in a comment and say no check-in, just like that. And if it finds that, it won't actually allow me to check it in. I really need to set that up on this. I just haven't done it yet. So maybe we'll get to that tonight, actually. So that's that. And then here, we actually just do a check on the map to see if there is actually a texture assigned to that before attempting to release it, because that was another issue I ran into. Riacho, hi. First time chat. Welcome to the stream. How are you doing tonight? Welcome, welcome. All right. So that is, I think, it for the material system in this change set. Just started following the series. Welcome. Yeah, that's awesome. Yeah, we've, I think we're we're up to like 100 and almost 120 episodes, I think now. So I'm glad you're liking the series, right? There's a lot more that we have planned to do, and actually we're probably going to take a look at the roadmap tonight. So you're actually joining at a really good time. Let's see. I can't remember how to do it. I Google it every time I need it. Yeah, I think I set up a private repo with like a template of how to do it. So hopefully that's what I did. If not, I'm going to kick myself. But yeah, if I did, we should be able to set that up on stream tonight. All right. Okay, so there was another minor change I made. So this is actually in the game code here. So we had these sort of static hard-coded move speed, and I called this temp move speed because this is rubbish, right? This is not how we want to do this. So I actually created something on the state called forward move speed and backward move speed, and we use that instead. And so that's what we basically did here, and this allows me to control that a little bit easier, but also to use my hot reloading. So if I want to change the camera speed, I can do that, right? So that is that. It's a minor change, but it keeps it from being static. So you know, we could just reuse. Or we can recompile and get a new value. Eventually, we'll probably tie that to a UI control, but this is sort of the first step with that. Game state. So here is where we added those two speeds to the game state. So sometimes we want to move backward a little bit slower than we move forward. So I decided to split those up. Here's where we set the default values for those things. So forward speed is 5, backward speed is half of that, right? The other thing is I moved the camera. And this is actually another thing to do on my list. I want to add something to the scene that maybe gives a default camera position. I haven't completely thought about how I want to do that yet, because there's some issues revolving around that. If we want to load multiple scenes at once, then how do we determine which one to use, right? But for now, I've gone ahead and just updated that in here. And then it looks like the Vulkan backend, I just fixed a minor bug that was here, where it was only checking for the map, but it should also check that that map has internal data before actually trying to do any of this stuff. And that was for releasing texture map resources. Because there were scenarios where we might try to release those resources more than once, which technically shouldn't happen, but if we do, at least in this case, we catch it, right? And so that's it for that one, I think. Yeah. And I think the rest of these are much, much smaller, right? So this one, I think, was mostly just bug fixes. So here there was a copy pasta issue in the error string there. In the render view world, the code for this was actually kind of wrong. And so we've gone ahead and fixed some of the issues with that. I think the biggest thing that did we do that in this change sets? I think we did. Let me expand this up a little bit. Yeah. So one thing that we were doing before was we were checking the terrain count to make sure it was greater than 0, and then sort of looping through this anyway for each terrain, which didn't really make any sense. So we've moved that in a level, right? So most of this was correct. We just had to kind of scooch it in a little bit. I think that's it, though, as far as what changed. Riacho, thank you so much for the subscription. I appreciate that. Thank you for the Prime. Greatly appreciate the support. Thank you very much. So yeah, that's all we did here. We just kind of scooched that in one scope, and I think this is actually the same thing down here. Yes, so the other change that we made was we had this sort of shader system used by ID, which is for the material shader, and then we were also applying globals, but there was the potential that we didn't have anything in the scene to actually draw. So it makes absolutely no sense to use this shader and apply the globals if we don't have anything to draw with that shader. So what we did was we actually moved that logic inside this geometry count check. So that way we're not just doing it always, regardless of whether or not we have something to draw. So most of this is just kind of moving all that stuff in scope. All right. Let me see. Let me catch up with chat here for a second. Windows just detected a simulation file output as a virus. KEKW. Wow, that's terrible. Virus detection is not an easy thing to do, admittedly, but yeah, it tends to be wrong a lot. I'm a beginner, but from the languages I've experimented with, C is my favorite, and I'm interested in learning about engines. So when I found your channel, I was like, that's it, perfect match. Awesome. And Linux support. Yes, we are on Linux at the moment, actually. So I'm using Arch Linux, but I started this off with Ubuntu as well. So, you know, it supports, I want to say, just about anything you'll throw at it. I do want to mention that the windowing system is only supporting X right now. I don't have official Wayland support, but Wayland is also capable of intermingling with X, so it shouldn't be an issue. Windows antivirus thing hates compilers. Yes, it does. I thought MinGW was broken, but no, it was just eating the compiled exes every time. Oh. It's stuff like that that really makes me annoyed to work on Windows. Like, God, that kind of stuff's really annoying, especially if you set up your own tools and run stuff from the command line a lot. Yeah. Thank you for joining. Yes, but in this case, it was literally an ASCII encoded file compressed as gzip. Jeez. How did it think that was a virus? I wonder what byte mark or byte sequence did it find that it thought that was a virus? Finally got your Ocean Sim to work. Ooh, sweet. Nice. Number one reason not to work on Windows. No ASAN. You have ASAN. Oh, address sanitizer. Yeah, okay. Anyway, let's see, where did we leave off? The shader system. So this was actually kind of an interesting bug. So I basically commented out this check to see if the current shader was actually the already being used. So whenever we say use by ID, we're checking whatever shader was currently is currently used to see if we need to use it again, right? This was a little bit of an optimization, but the problem is if you've used that shader on one frame, right, and you get ready to go through a next frame and you don't use that shader again, Vulkan actually doesn't like that. So in this case, I actually had to remove that. I commented it out because I want to add a little bit of detection in there to see if it's the same frame or not as well. But for now, I just commented that out. So to get around that bug. All right. I think that's actually it for that one. So like I said, the rest of these are pretty small sets of changes. This one is more test scene updates. So this is just like positions and colors and stuff like that. The other thing I did is I went ahead and swapped out the skybox because the skybox I had in there was a bit rubbish. And this one just looks a little bit better. So it's a much smaller image, but I think what we wound up with was a nicer result. So you guys will see that once we get to it. We added a 4 pi definition here just because we needed that for something. We also added a lot of debug code to this. So this helps with our debuggability a little bit. So render buffers, we were running into some issues where render buffers weren't getting freed correctly. And they were basically trying to be freed while they were still in use by a command buffer. And some of the extensions, the Vulkan extensions that we actually use for debugging, can tell us what the name of one of those resources is if we provide one. So what we've done here is we've gone ahead and added a name to the render buffer create to assign a name to it. We go ahead and grab a copy of that, right? And then, let's see. This is just the free of that to clean that up. That's the H file. In the backend is where that change really gets useful, right? So it just more or less passes in from the front end. Here's the change to the structure to store the name. And then let's skip simple scene and go to backend real quick just to kind of go over that change individually. So where is it? Okay, I'm just going to look for it here. So in Vulkan backend, what we do is we do a little bit of string formatting, right? Depending on what we're going to name the individual render buffer. So this is basically just passing in names. So we've got our global vertex buffer for global geometry. So here's the name for that. And we just pass that in. Here's the one for the global index buffer. Here is one for staging. So this is the staging for texture writes, the staging for texture reads, the texture read pixel staging, right? We did also fix a small bug here where geometry internal ID wasn't being set to invalid ID when we're destroying a geometry. So we did that. Here's another place where we were setting like a render buffer global uniform buffer, right? So we have a name for that. Most of this is just formatting stuff. And then here, where we're actually allocating the memory for the buffer, right? This is in Vulkan buffer create internal. So our front end calls this, passes along the name. We go ahead and allocate the memory, but then we also use our Vulkan set debug object name. And this is where we pass the buffer name, right? So by doing this, this gives us greater debuggability when we actually have issues. So that way we know what actual object we're dealing with. It's a little bit easier to manage this way. So that's the primary fix for that. We also added a VK device wait idle for the destroy, just to make sure that when we're destroying a buffer that it's not in use. And let's see, this was another allocation of memory for buffer resizes. So again, it just kind of uses the new buffer name, right? So it allocates the memory, sets that debug object name. Here's another place where we're adding a name. Here's another place where we're adding a name, right? So most of what the changes in this were actually to support that name change, or the ability to add the name. So that's that. We also had to do it in one place in the image. So when we're allocating memory for the image, we actually needed the image name to be passed there, right? So we're doing this Vulkan set debug object name for the image memory, and we're using the image name. So it makes it a lot easier when we're debugging issues with that to say, hey, what the heck, what is this memory, right? Because a memory and just an address doesn't really do us a whole heck of a lot of good without knowing what that's tied to. All right, let me just check chat here. I like MSVC's debugger, 11 out of 10 good, the rest, no. I mean, it's fine, but no. Yeah, its debugger is pretty good, although it's kind of slow, but yeah, it is really good. There's not really another one out there that's quite as powerful. I know GDB is pretty good, but it doesn't really have a UI. It's not quite as quick to use. I'm not as quick with it, for example. Their STL implementation is actually pretty good now, and they are relatively fast implementing new C++ features. They do, however, like other compilers as well, break the spec sometimes. Yeah, they do. Yeah, I don't use the STL if I can help it. Honestly, I don't know what the draw of GCC is compared to Clang and MSVC. I mean, if you do lots of C as well, then yeah, you don't use MSVC. Well, I mean, Clang on Windows defaults to that as its backend, unless you install GCC and tell it to point to that instead. Okay. So, I think the other stuff is mostly bug fixes. One I want to touch on real quick is the material system here. There was a small issue in here where we're basically loading up our terrain material. I think it's a little further up. So when we're loading our terrain material and we come in here and we get, where is it? Get these materials by name. We had a bug in here where we actually weren't releasing those. So we just need to release those down here. So that's all that is. The debug console actually had some issues with it. So there were basically some issues with its text object being or trying to update if it wasn't yet loaded. So what we've done is we've actually added a loaded flag to the debug console. And then we've gone in here and basically put that in a few different places. So in other words, if we, when we're executing the debug console consumer write, in other words, when it receives a message from the console, the in-game console, if it's not loaded, it basically just boots out. Some of this is formatting stuff. The key presses, again, if it's not loaded, just boots out. Here we are creating some UI texts. The UI text, we actually added names to UI texts for the same reason that we added names to the buffers, right? So the render buffer, the UI text actually does have its own render buffer under the hood for right now. And so we've actually, we need a name for that. So the UI text now has a name that gets passed through. Here we're just handling more loaded state, and I think that's it. So that is debug console. Game state, we actually have a running flag in the game state as well. We'll see where that comes into play as well. Close. There we go. So in testbed main, the first thing that we do during application boot is we set that running flag to false. We've gone ahead here and added some of our names to our UI text for that. So we have those two different text objects on the sort of main screen there that aren't associated with the debug console. So we've added names to those. We went ahead and changed the positioning of some of these elements. We go ahead and set the running to true. And then here is where we actually go ahead and use that running flag. So in application update, if we are not running, then we actually don't want to perform any logic in this, and we want to boot out earlier. So we have a little optimization there. I also fixed a bug with, so if you recall in a previous video, we actually had one of our point lights not only moved in space, but also cycled through colors in the RGB. scale. And so what we actually did here is we put some fixes in for that, because this was actually just kind of going, I think, to like red and then like default zeros all the way across. And so it was like red to completely transparent and then back to red, which is not what we wanted. So we needed to offset the R and the G and the B from each other. And so we actually have a more correct method of doing that here. And then we also changed from moving the light position on the x-axis to moving it on the z-axis. Here's another state running check. So we don't update the UI text if we're not actually running. The render, again, we boot out if we should not be rendering because the application is not running. And then when we shut down, we flip this flag to false. Right? All right. So that is that. Close. All right. This is the header for the UI text. We've already been over that change. It's just to add the name. So we'll get rid of that. And then I think the last thing we have, oh, this is the UI text implementation. So we have the name here. We keep a copy of the name. We add the name to the render buffer, right? So we just say render buffer, vertex buffer, UI text underscore name. Same for the index buffer, right? So we just add those. And then obviously destroy it if we have a name. So that's all that is. It's really nothing more than a pass-through. Okay. So this is terrain C and simple scene. So simple scene had a couple small fixes. We weren't zeroing out this new terrain object, so we went ahead and did that. And then we also, in the simple scene actual unload, we loop through and actually unload the terrains because we actually hadn't handled terrain unloading yet. So this adds terrain unloading for us. So we basically loop through, unload each one, and then destroy it. Right? So that's all that does. And then we destroy the terrains array if it exists, and that's it. Right? So that's the simple scene fix. The terrain C, we mostly of this I think is just the destroy, right? So let's see. So in the create function, we added some logic here to invalidate the geometry because that wasn't being done, needed to be. And then when you load that, that's when those IDs actually wind up getting replaced with valid IDs. And terrain destroy, we're just cleaning up the name, the vertices, the indices, the material names, the vertex datas, zeroing out everything, and then we're done, right? In initialize, we were zeroing out the whole geometry structure, but we should not have been, because that was getting rid of some invalid IDs that had been set during creation that we need, because invalid IDs are not zero, right? And then unload basically just releases the material and destroys the geometry, right? And that's all there was to it, right? Unloading, thankfully, is pretty simple. I think that might actually be all the code. So that is it for that change set. I know it seems like a lot, but it's really not a lot of code. Like most of this was just that image, right? All those images. So that's that one. And then the last one is the smallest commit out of all of them. And this was just basically to fix the mesh loader where we load in a OBJ file and the OBJ material file. When we were writing our version of the material file out, that was actually wrong. And so we went in here and actually fixed that, right? So in this case, we had to create a properties and maps array, which wasn't being done. We have some cleanup here for that. We'll clean up the name if we have it. And then this is where we actually keep a copy of the name if we have it, right? And then we're also missing some lines that were being written out. So the map opening and closing tag and the property opening and closing tag, we were missing those. We were writing all the data, but we weren't actually, we weren't writing out let's see, I think it was cobblestone. We weren't writing out these tags, right? So we went ahead and fixed that. And that is it for that. So that in combination with everything else that we've done for both the material system redo and the terrain system is all here. So we have 31 commits and 128 files changed. So this is kind of a big boy, right? So I am going to do this as a pull request. That way it's very easy to see exactly what happened here. So let's see. Let's call this terrain redux, oops, material redux and terrains. I'm going into main with that. And it's blocked because I have to review it, right? But that's fine. So here is our massive list of files changed, just so that you guys can see why this took several videos and streams to get through, right? So this is the list of files that have changed. So this was a pretty big feature, right? So what I'll do is we are going to squash and merge. And let's see, did we... I guess I could leave this here. And we can nuke the branch. Now that is merged into main, you guys can pull it. So, with that out of the way, let's go ahead and I'm swapping to VS Code just because I like its debugger better. I kind of talked about this a little bit off stream or on stream last time. The debugger that I had set up in Vim just wasn't really all that good. So when I'm debugging, I'm just going to do it in Visual Studio Code from now on. Let's do git checkout main. What changes do I have? Oh, right. Because I made that change. Yeah, whatever. Okay. Is that it? Okay. Cool. So now that we've got that pulled, I'm going to do a clean and a build. And I'm also going to do a post build. Just rebuild all of our shaders. And let's go ahead and run. So we've got our window here. If I go ahead and load this up, we'll see that we get our temporary textures before we load our full high definition textures. Let me get VS Code out of the way here so we can actually see this in full screen glory. So this is what our terrain looks like right now. We can see that we've got our light going back and forth here, changing colors. If we look at our lighting only mode, we can see that those are interacting with the terrain as we would expect. We see here that we have lighting and shading on the terrain as we expect. So all of that looks good. Our normals look good as well, at least for this. This is the sort of Sponza scene over here. So this is sort of an older version of the Sponza scene, so it's got some issues with geometry. But that's not Kohi's doing. That's actually just the model itself is borked. And then if we have a look at Sponza in here, it looks fine as well. So everything is sort of working pretty well together. If we go back outside here for a second, probably the clearest place to see the difference in terrain elevation and the materials is here, right? So we can see our 4 materials are being interpolated there. And then we can see a nice smooth transition between those here, right? So all of this seems to be working as we expect, but there are a couple things that I do want to show you guys. So let's go ahead and quit out of this for right now and move this back over here. And I'm going to go to terrain.c, and where we're setting the weights, if you recall, I said I was going to come back to this, where we have this sort of tiered if statement, if else statement stuff, right? So basically what we're going to do here is look at the height data and say, well, if it's less than 25, right, then we're going to just use a weight of 1, or a weight of 1 on index 0. If it's between 25 and 0.5, we're going to use a weight of 1 on material 1, and so forth all the way down, right? So instead of this, that's what we're going to do. So what are you guys thinking this is actually going to look like when I load it up? Just out of curiosity, how do you think that's going to look? See, MSVC's C support is pretty good now. It's mostly C11, or was it C17 compliant? Yeah, they finally got around to C17 compliant. Well, I don't know if I could say compliance across the board, but they did finally update that some time ago. I want to say it was in the last year or two. All right, so anyway, we'll go ahead and run this. And let's get VS Code out of the way here. And we'll load up our scene. Look how much different that looks if we don't actually have that smooth step. So what we get is these sort of really hard transitions between one material and the next, right? And so that's why we need that smooth step to smoothly transition between one material to the next. Otherwise, we get these super hard edges, right? And so eventually that won't really matter, because the height-based terrains texture assignment is really only going to sort of be a default. And it's going to be expected that you go into a terrain editor and edit this afterwards, right? A couple of other things that I want to mention is that we don't have any mip mapping yet. So that's why these textures kind of look crappy off in the distance. Mip mapping is something I'm probably going to handle all in one pass sometime soon. But, you know, it's not a huge priority yet, right? Let's see. I think they're on the ball with C23 too. Yeah, I couldn't tell you on that. Better than we only do ANSI nonsense. Yeah, I agree there, for sure. Although I'm not using really what I would call modern C. I still kind of stick to the basics. All right. All right, so what we can do is undo this. We can get rid of this now. The other thing, I think this is actually already done as well. I think we do that down here. Yeah, we do. So I'm actually going to get rid of that to do as well. Oh, we don't have this yet. We probably should do that at some point. We should probably also have like a central origin on the terrain at some point as well. Although I guess top left kind of makes sense. One thing I did want to take a look at is, I think it was, where did I see that issue that I wanted to fix? I think it was in the fragment shader. Yeah, this normal. So the default normal on here is on the y-axis, and it should be on the z-axis, because z is what points out, right? So that, I think, was wrong. Let me verify that. Oh, I forgot to rebuild the engine. There we go. I think that's actually correct now. I think our normals still wound up being correct anyway. But they might have been ever so slightly off before. So I think, I mean, the lighting looks correct. Actually, the lighting looks a little bit better to me than it did before. Yeah, I think that's actually helped us out. So, okay. All right, so there was that. Was it material system? We had some code in here we wanted to get rid of. This material 47, we don't need that. Just checking real quick to make sure that we don't have anything else that needs to do. No, I think we're good. Okay. All right. So I think that's going to do it for these changes to materials. So what I'm actually going to do, I think it was only those, yeah. Fixed various terrain bugs. Good enough. Bypassed rule violations. Yeah, that should work though. That should have done the thing anyway. Let me see. So yeah, okay. It doesn't like me pushing the main. I try not to do that, but every once in a while it's kind of necessary, you know? All right. So I guess the next thing that we can do is let's have a look at the roadmap. I've got some ideas of some things I want to work on next, but we'll have a look at the roadmap and go from there. So if you guys aren't aware that this wiki exists, there's not much in it yet. I still have to build it out, but there actually is a wiki here with some information on it, right? Things about goals and whatnot, but the most important thing is probably this roadmap here, which has all of the features that are planned, as well as ones that are done. You know, it's got all kinds of stuff in here for us to visit. So let's see, did we have terrain is in here? So we actually need to edit this guy. And there's a possibility that we've actually done more than just this, but let's go ahead and let's move terrains to done. And these are in no particular order, so as I mentioned here. You know what? I'm going to save this. It's a little easier to read in this format. Okay. Mobile runtime support, that's like a really low priority thing. I don't plan on doing that anytime soon. SIMD it's an optimization level thing. I'm not really going to worry about that just yet either, because that's kind of a whole thing on its own. Dynamic arrays, I do want to revisit those. Not super important though. I may wind up doing that off camera. Some various other containers. I thought we had the ring, actually. We do have a ring queue. I think we're even using it. Yeah, our job system's using it. I thought so. So that's actually done. So let's get that out of there. Let's see, do we have anything else in here for like containers? I don't think so. Let's do this. We'll say dynamic arrays and rings. We also have, bring this back on screen so you guys can see what I'm doing. So we have free lists, hash tables, and stacks. Oh, stacks are actually in there as well. I think that was up here. It is. So stacks. We also have hash table. And what was the other one? Free list. All right, so we have those. So a queue, a pool, and a binary search tree. Binary search tree we're probably going to need when we get to some of our more advanced features, like searching for something in a scene by name or something like that. For now, I'm not going to worry about that. Logger, we want to add multi-threading to that. That I could probably do that offline. Particles, that might be an interesting one. Input mobile, input gamepad support, string library, k-string structure. So this is something I want to put in place, but again, I feel like that's probably not something I'd do on stream. Pool allocator, that would be based off this pool here. In fact, they might wind up being the same thing. That might be an interesting one. Binary file format for textures with a converter. That's probably something we should look at sometime soon, along with resource hot reload, ECS prefabs, raycasting, object picking. So we have one of two methods done on that. Gizmos. Gizmos, I feel like we're going to need that sometime soon. We have audio and physics. Audio we're going to need sometime very soon. Networking, profiling, proper editor, and runtime binaries alongside testbed. So world editor, UI editor, game editor, logic library with hot reload. Well, actually, we already have the game hot reload. So that's actually just that. Timeline system, skeletal animation system, Skysphere, i.e. dynamic day night cycles. So we want to add that as well. Volumes, pre-computed visibility volume and other types of volumes like triggers for gameplay, physics volumes, weather occlusion. That I feel like we probably shouldn't do until we have some of these other systems in play. These other backends, I don't know if I'm going to wind up doing those on stream or not, particularly like for OpenGL. I might just do that off stream. Geometry generation. So that's just some more generic types to generate them in code. So that might be, I'll probably do that off stream as well. Let's see. Advanced materials, PBR. Advanced materials. I guess I couldn't really call the Redux advanced materials yet because we actually need, well, I guess we could because it's more configurable, right? So maybe. This is kind of work in progress. Batch rendering, shadow maps. Shadow maps are something we should probably tackle soon. UI, this is a big one. Like, this is going to be one of those things where once we start it, we're going to be in it for a while. Okay. So I feel like there's probably some other features we are eventually going to want to add to this list, but for now, I think that's okay. Oh, you know what? There actually is one more thing I can think of right now. I'll put it here. A water plane. So that we can have some basic water in the scene. All right, which one of these do we want to pull next? I feel like maybe some gizmos might be the thing that we do next because we're getting close to the point like, so let me show you guys something that, I was doing sort of off camera that makes me say this. So we'll open up the test scene. We'll load up the game. Load the test scene. Now, we do have the ability right now to say, well, what if I wanted this this directional light to be, I don't know, way more red, right? So we could say 1.0 instead. Well, we could save this, unload the scene, reload the scene, and now it's more red, right? And so we can kind of do that dynamically, which is cool. Or if I undo that, let's say that maybe we wanted to move the Falcon over a little bit, right? So maybe I say, I don't know, 60 here instead, right? And we unload and reload. And now it's bumped over a little bit. This kind of workflow, while it helps to not have to sort of completely relaunch the engine, we are having to reload sort of everything here. Now, you could say that, you know, maybe this is where we hook up asset hot reloading, right? And that would, anytime we change this file, it would just automatically reload. But I don't feel like that's really great either. I feel like we're kind of getting to the point where it might be nice to have an editor where we can actually click into the scene and select an object and maybe move that around, right? Speaking of that, actually, so you'll note that we actually need to add the terrain to our picking code because it's not being rendered there, right? So if I hover over the car here, we see hovered 11 here at the bottom. So if I hover over that, we can see that it's picking that fine, but we can't actually pick the terrain. Right? We can hover over spawns over here, and we get 10. But we can't actually get the terrain. So we need to add object picking for the terrain, and then we need to add a couple of other nice to haves, like a gizmo to show us what direction we're currently facing, or to be able to interact with objects. So I can click on this car and be able to sort of move it around or rotate it or drag it around. A grid might be nice so that we can actually see, where we are in the scene. Things like that might help us out quite a lot. And so I think it's time that we actually start looking into building an editor. And we're still going to use, at least for right now, we're still going to use our sort of testbed application to test these new features as we add them. But eventually we are going to solidify this into its own sort of application and go from there. So I think what we'll do tonight is we'll start by adding some logic to render the terrain, so that we can actually pick that. The only thing that I think we're going to run into a problem with is if we have a look at our shader config for the world pick, we do have a little bit of a mismatch here in terms of attributes. So if you recall, our terrain has this extra mat weights. So if we pass this structure into the world pick shader, it's not going to work. So what we're going to need to do is probably create a new shader that is essentially the same shader as this guy, but has one more layout location. And then that's really going to be it, right? It's just going to use everything else identically. Because all we really need in this is just the position, and then the fragment shader just references the ID, right? Which means that we actually have to add an ID to the terrain as well. So I think that's probably where we'll start. So let's do this. We'll call this terrain pick. Right? It's still going to use the same built-in render pass. I think we can get away with that. We have vertex and fragment. We need terrain pick shader. Terrain pick shader. We do need depth test and depth right for this. And then let's just go ahead and copy over this attribute. Everything else should be the same, basically. So we'll then take the world pick shader and we will call this terrain pick shader. And that will take, terrain weights. And then we'll take the terrain, or I should say not the terrain, the fragment shader for world pick. And we will rename that to terrain pick shader, and that will remain the same. So we have that. We will need to come down to our build, our post-build batch file and shell file. And I'm actually just going to copy this here. Terrain. So that's updated for Windows. And then for everything else, you have that. So there, post-build works. So we should be able to actually go ahead and run task post-build, and we should get our terrain pick shader being written out. And it looks like those compiled. Okay, so that's done. So we don't need those open anymore. So I think all we should have to do is go into the render view pick. And let's see where we are loading up all the things. We're basically just going to have to do the same thing that we're doing for the existing shaders here. So let's see, we have the UI pick shader here. So it looks like we load the UI pick shader. And then we extract the uniform locations, set some defaults. And then we do the world pick shader, extract the uniform locations, set some defaults. So we're basically going to wind up duplicating all of this. So let's just actually do that. Right? And then this is going to be built-in terrain pick shader. This is going to be built-in terrain pick. Change the error messages. Change this error message. This is going to be terrain shader name. And then we have up here the shader info, which is going to wind up being the same structure. So we can just call this terrain shader info. And let's see. We might just have to do a manual replacement of all these guys. Okay. All right, and we've moved on. Okay, so that should cover us. Okay, so that's initialize on destroy. I don't think we need to do anything there. Resize. We have some projection matrix changes here, so we're going to need to do that also for the terrain. Actually, we don't need to recalculate that. We can just say terrain shader info projection. Take the FOV, aspect, near clip, far clip. That should be good there. When we build the packet, we have, let's see, iterate all geometries, iterate all meshes, and count UI text as well, because we can pick those. Okay, so the only thing I think we have to add here is the actual the terrains. World data. So what we'll do is take this and say terrain geometry count. And this will be packet data, world mesh data. Where is world mesh data? Let me see. Packet data. Pick packet data. Okay, so we may have to do some stuff in here as well. We'll see. Let's see, world mesh data. Yeah, in fact, I'm pretty sure we're going to have to geometry, render data, and this is going to be terrain mesh data. Right, and this is also a copy of the frame data D-array pointer, right? So we have one for world meshes, one for terrain meshes. So now we should be able to say terrain mesh data, right? Terrain geometry count. This is going to be out packet terrain geometries. And then packet data terrain geometry count. Whoops, terrain geometry. Terrain mesh data, rather. Wait. Yeah, terrain mesh data. Sub I. Which is geometry render data. Okay. Count all geometries as a single ID. So this needs to be terrain mesh data. Terrain mesh data. Okay. So I think that's all we need to do is we basically just needed a copy of what we were already doing for the world geometry. Oh, did I just clobber the original code there and not actually make a copy of it? I did, didn't I? What a dingus. Okay, so let me switch this back to world geometry count. World mesh data, okay. Okay. All right, so that should be terrain geometries added to the packet. Okay, so here are the geometries getting drawn. Let's see. Render pass begin. So here's the world shader. We apply the globals, draw each geometry, and then we end the render pass. And then the next render pass is here. So we actually want to do and world geometries, terrain geometries. We want to do the same thing, but for terrains, right? So this is going to be terrain shader info. Right, so we're gonna again just manually replace these things because they should be the same. Okay, and this is gonna be terrain geometry sub I. Swap out a couple of these things. Let me just make sure that we've covered everything. This needs to be terrains, terrain geometries. Oh, you know what? Let me just... terrain geometry count. Terrain mesh data. Terrain mesh data. Okay. I don't know that our logic with how these things are going to line up is going to work. We'll try it and see. By the way, just a reminder, if you guys have any questions about any of the stuff I'm working on, feel free to jump into chat and ask. And I will, you know, I do keep an eye on it, so. All right, I think that is all I need to do for that. This is all the UI stuff, so that doesn't matter. And then we just read the pixel data. Okay, I think that's it for the pick. Let me try to run this. Something tells me it's probably not going to work correctly, but we'll see. Yep. So we have a seg fault. That's always fun. Pass internal data. Oh, pass is... pass is null. So we don't have a... terrain shader info isn't being populated. Let's see. I thought I did this. Didn't we? Config resource. What did I miss? Terrain shader name. All right, let's debug. So our config looks like it's loaded correctly. But there's no pass. Oh. Didn't add it here. That's why. This should be the same pass as the world shader info pass. Yeah, now it works. Okay. So continue on with that. Load the scene. Okay, so we're still not... We're not getting any sort of picking here. I suspect, though, that might be that might be, let's see. It's called unique ID, isn't it? Where we read in ID color, unique underscore ID. Let's see. So I wonder where we are assigning that, because so the UI text has it, mesh has it, but I'll bet our terrain doesn't. Yeah, our terrain doesn't do that. So mesh load does it. UI text create does it. Go ahead and do this during load, right? So right here we'll set the geometry. It's not on the geometry? I thought it was. Oh, it's got to be in the top level object. Okay. So we need to add to terrain. Could have swore we already did this, but apparently not. That's going to be a U32 unique ID. And then this will be terrain unique ID. We'll set the owner to that. We need an include. I think that's under core, I want to say. Core identifier. So that should give us a unique ID. When we unload, we should probably also unassign that. So T, unique ID. I think that should be 0. Might have to be invalid ID. We'll see. And we're still not getting it. Okay. So let's go back to the view. And where we are drawing the see, that's the world terrain. Oh, because we probably didn't copy it over, did we? Right. Because we had a to-do here. That's why. So we can finally get rid of that guy and say scene terrains sub I unique ID. All right, so what is it? Let's see. Let's go back to render view pick. Let's have a look at this. Breakpoint. Oh, interesting. We're not even hitting that breakpoint. Terrain geometry count. Terrain mesh data. Oh, you know what? That's probably because we are not creating the terrain mesh data in the packet that we send through. In fact, I can guarantee that's the case. That's also going to be a simple scene fix. Packet build. Scene world data. So the world data is passed through as the freeform data. So we have data. We get the pick packet data here. Terrain geometry count. Terrain mesh data. So is the simple scene not passing that through? So the world data does have terrain geometries. Train geometry count. Ah, okay. So we weren't creating this for one thing. Let's have a look at that real quick. Terrain geometry count is 0. Packet data. So when we're building the packet, I'm guessing, because this doesn't even exist, right? So this is packet data. Pick packet data. So simple scene is just passing the world data. World geometries. Wait, we're casting this as the wrong kind of structure on the other side. We're casting this as pick packet data. But what we're passing is render view world data. It's probably not going to work because I have to include that. So this packet data, wow, this has been wrong the whole time. And it only worked because it happened to be another array of the same thing. UI geometry count. So the packet data. Okay, this is named wrong. This should probably be in data. And then packet data. Should be a cold cast of out packet extended data. And then we can move this here, packet data. And then this should be world geometries and terrain geometries. And out packet. I guess we say packet data. world mesh data. That doesn't seem right either. Oh, this should be world geometries. Okay. And then in data, world geometries. I'm surprised this worked all that time. It's been wrong for like months. That's awesome. Okay. So this should be packet data, terrain mesh data, terrain geometries, terrain geometries, terrain geometries, and then this should be packet data. Not 100% sure this is right. Done a great job at confusing myself on this. Let's see if this runs or just crashes hideously. Oh yeah, it's definitely not right. Okay, so the simple scene. Oh, wait a minute. Oh. I edited the wrong thing. I'm looking in the wrong place. Undo all of this. Undo all of that. Don't need this either. Okay. That's not where that transition happens. That transition happens from the world rendering to the pick rendering. I want to say in the testbed main. Is that where that was? So here's where the views are read in. Populate render packet. Here's the UI pack. Here is where it is. Okay. So application render is what puts that together. So this should be pick packet, terrain mesh data equals packet views sub1 terrain geometries. That's what needed to be passed through, and that was all that needed to be passed through, I think. Pick packet data. Okay. Let's run this. There we go. We're rendering. Okay, so it looks like we are getting some sort of errors in the console here, so let's pop that open. Oh, weird. Bytes to code point was failing. Let me run this one more time just to make sure that... Yeah, it definitely doesn't like something that's going on there. Let's see. It's probably... Drain geometries. So we push into that. When we do the on render... Oh, I'll bet this is where I was saying these won't line up. I'll bet that's probably what I'm running into now. Okay, so this whole start from 0 since world geometries are added first and stop at the world geometry count. So world geometries, then terrain geometries we're doing, but I think we did the opposite up here. Or did we not? We did world. And then terrain. Okay, let me move this down here. Okay. Okay, so I think we're adding those in the correct order now. So we do world meshes, then terrains. And then when we go to render that, we do world, and then terrains. But we can't start from 0 here. We need to actually start from world geometry count. And then do up to terrain, and then the third, when we start the UI, is actually going to have to be world geometry count plus terrain geometry count. Let's try that. There we go. Okay. Well, it at least runs properly. We're still not getting an ID, though, which is very strange. So let's do... Let's see. Let's go in here to this guy and put a breakpoint there. Oh, we don't have... Aha, okay. I see where the bug in the logic is, actually. So this needs to be added in here as well. Otherwise, we're never going to hit that, right? Oh, dang it. Geometry, unique ID. So we do have a model matrix. Segmentation fault. Geometry. Okay, and I'll bet this is, oops. Terrain geometries. Unique ID, so that did get copied over. But the internal geometry seems... Internal ID. Its ID is invalid. Does have a material. Geometry render data. Oh, repassing the... Oh. I think I know what the problem actually might be. We're passing the geometry itself, and I think it should be passing... Geometry render data. No, it is passing the geometry render data. Oh, but I is... okay. Yeah. That's not going to work either. So actually what we need is... We need a new one called J. Actually, what is... Terrain geometries? No, this thing should just have... That should just be that. It's later on that we have to do that. I think. Nope, didn't like that either. Terrain geometries. Current instance ID. Let's see, is this... Okay, this should not take into account terrain count then, I'm thinking. Because I think we jammed the UI geometries in with the world geometries, which is what is making it so confusing. We probably shouldn't be doing that. We should probably just split them out. All right. Well, I think, given the time, I think I'm going to have to actually call it quits tonight. I was hoping to get this implemented, but I was a little bit skeptical as to whether or not that would actually work out of the box, because I knew I was going to have to add a shader, and I'm probably just missing something stupid here. But I will figure it out, and we'll go over it on the next stream. So I'm thinking it's got something to do with the way that the instance IDs here are working, and the binding of those geometries in the order that they're being added to the packet, I think. So what I'll do is I'm going to call this bug fix. Wolf, thank you so much for the follow. I appreciate it. I'm going to call this bug fix and then terrain picking. Actually, you know what? I'm just going to call it terrain picking. I need the B flag for that. Work in progress. Terrain picking. Picking. All right. So at least that that branch will actually be available on the production repo. So what we'll cover next time is we'll go ahead and wrap up the terrain picking, because we are going to need that. And then once that's done, we'll go ahead and start creating some of those. We'll create like a grid. We'll create a gizmo to like be able to edit stuff. And then we'll actually hook up some object picking correctly so that we can actually maintain a selection within the scene. So that way we can actually click objects and select them, and then we'll be able to interact with a gizmo and things like that. And once we get to that point, I think it'll be a decent starting point for us to kind of start splitting off into creating our actual editor. So anyway, I'm going to wrap up the stream for tonight. Thank you guys so much for following along and being here and all the support. This will be uploaded to my YouTube channel, which is travisroman.com/ youtube.com/travisroman. And it will be available there as well. If you're not following me on there, go ahead and head over there and subscribe to get updates on the project besides what we just do here on the stream. And yeah, I think I'm going to go ahead and call it here. So thank you guys so much for being here, and I will see you guys on the next stream.